I also had question 6. So for the first part A, we have to show 2 cases in order to show that it's a homomorphism. So the first thing that we're going to do is we're going to consider alpha of v plus w. So if we have alpha of v plus w, we'll have v prime of x plus w prime of x plus cosine x times v of x plus cosine x times wx. If we just rewrite this and group our v's with our v's and our w's with our w's, we get v prime x plus cosine x times v of x plus w prime of x plus cosine x wx. So then we can see that this is just saying alpha of v plus alpha of w. So we've proved the first condition. Now we have to show scalar multiplication. So now we're going to consider alpha of av, which would give us av prime of x plus a cosine x vx. We can factor out an a, so we get a parentheses v prime of x plus cosine x v of x. But in our parentheses, that's just alpha of v, so we get a alpha v. That proves both addition and scalar multiplication. So now we can say that alpha is a homomorphism. So then for our second one, we had to find the kernel of alpha. And when we're looking at the kernel, it has to equal 0. So we're going to take our alpha of f and now look at it as if it was 0 equals, instead of f prime of x, we're going to look at dy over dx plus cosine x times y. So this is separable. We can separate the x's with the y's. So the first thing that I'm going to do is subtract cosine xy on both sides. So I get negative cosine xy equals dy over dx. So now I want to get all of my x's on one side and all of my y's on the other. So I'm going to multiply by dx on both sides. These will cancel. And I'm going to divide by y on both sides, and these will cancel. So I get negative cosine of x dx equals 1 over y dy. So now we can integrate both sides. The integral of negative cosine x dx is negative sine x plus some coefficient, constant, not coefficient. And that will equal, the integral of 1 over y is the natural log of y plus some constant. So now what I did from here was I solved for y. I got y alone. So I brought my constants together. So then I got negative sine x plus some constant, I called it C3, equals natural log of y. And we can get rid of that natural log by raising raising both sides to, I can't think of how you would say that. but we're basically going to do this because these cancel out. So we're left with e raised to the negative sine x plus c3 equals y.